Okay, well, as our speakers come on, I'd like to, I know we're getting, running a couple of minutes late, so we're going to jump right in, but we have Chris Purdy from CENX.
Thanks.
Over there on the far end, Patrick Ostiguy from Accedian, and Claudio Mazzuca from EXFO. And so we have this panel on technology innovation. So we're going to cover a couple of different topic areas. A lot are focused around assurance, service assurance, but some on the LSO area. So the way we're doing this panel format is each of the panelists will be able to present a brief presentation of some material, and then we'll have a roundtable discussion to ask the other panelists to comment on the material, and then we'll move to the next topic. So we have a lot of topics we want to cover, so I'm going to jump right in and give our panelists lots of time to talk here. So first, Chris Purdy will talk about some areas in topology and inventory discovery. So Chris,
sure.
Pass it over to you.
So hi, everybody. I'm both CTO of CENX, and I'm recently appointed the co-chair of the LSO committee at the MEF. So I think a lot of my stuff is around LSO and how it works and what's happening in that area. So the picture on the right is a kind of a simplified version of an LSO. It's got a particular network domain down below, which might be a transport network or a carrier Ethernet network, et cetera. And it's really, you're trying to achieve two things. You're trying to provide a closed loop analysis and repair that's happening inside that domain with your LSO. But in addition, what you're trying to provide is a service abstraction northbound that hides the complexity. So you can activate a service, or you can change a service, you can delete a service, but you can also know the real-time operational state of the services provided by that domain, and you're hiding the complexity of the domain inside. The heart and soul of that is topology and inventory, and it needs to be accurate, it needs to be right, and it needs to be very, very timely. And historically, old inventory systems that were in play were often late, often wrong, and weren't updated appropriately. And I think there's been a lot of work going on in this area around having real-time inventory that can just respond to autonomous changes, that can keep track. And it's that much more important that it's real-time than it's ever been with the advent of NFV and with the ability to change. That's the dynamic nature of the inventory. So that real-time inventory component, you're seeing reductions in times to integrate and get the data sources in there. You're seeing that they're real-time as opposed to 24 hours late. And you're seeing that if you take a look at some of the MEF models, there's starting to form some standards of the information model that's presented by those systems.
Okay, great. Well, I'd like to open it up to the panelists. Talking about this has to do with real-time telemetry and being able to extract information from the network. And I know we're covering that in a couple other slides. But Patrick, would you like to?
Yeah, absolutely. This slide really talks to me because one of the things that our role as a company at Accedian is to feed into this and to facilitate closed loop automation, and if you've ever done closed loops at the university, I mean, those things only work if it's real time, if it's accurate enough, if it's granular enough. I mean, as soon as you start playing with these parameters, then the closed loop doesn't become that closed anymore, or doesn't respond to what it should be responding, and so on and so forth. So we're one of the things that we see in some of the early implementation of closed loop automation is the dependency on the information, on the instrumentation of the network, on the instrumentation of a multi-vendor environment in an equal footage, so that the arm doesn't react like this and the leg reacts in a different way, and so on and so forth. So we've actually seen out there some early implementations that do run into these challenges, and in the end it's finding a way to put together a common ground for instrumentation that is again, instrumentation not being hardware or software, just being, getting the information from the network into these kinds of systems so that they can act, quickly and efficiently and really realize the promise of optimization and automation.
Mm-hmm. So Claudio, any?
Yeah, actually, this slide resonates well for us, right, at EXFO. In fact, we acquired a company in March called Ontology Systems that's focused on real-time topology for assurance. And one of the reasons, as Chris mentioned, is understanding the topology in real time is going to be critical, especially as we move to more automated, software-centric services. So understanding that, and when you tie that, as Patrick mentioned, with some of the performance data, you can actually start creating closed-loop systems that allow you to automate troubleshooting. And without doing that, I mean, if you get to a software-centric deployment, it's going to be very difficult to operationalize those services. So real-time topology, coupling that with assurance and creating that closed loop is going to be key.
Okay, good. In fact, we have one on closed loop a little bit later we'll talk about. So let's jump now to the next one here. Claudio?
Yeah, so what I put together here is actually one of the areas that's been talked about a lot today, actually, is SD-WAN services. We believe at EXFO that this is one of the service areas that will actually benefit from automation and standards such as what's defined in the LSO. We've actually been very involved with the MEF, EXFO as a company for many years, pioneering things like the SAT test, which is based on our Y.1564, TWAMP. But one of the areas that we see will benefit from automation immediately is SD-WAN. And one of the things that I've been noticing as we visit customers is that there's a misconception in some cases that the SD-WAN controllers will be providing all the assurance that you need to be able to deliver this service. In fact, they have a key place. They do provide information in terms of what's available, in terms of application performance, but it's key to have, in our opinion, an overlay assurance solution that will allow you to look at a few things. Number one is when you're turning up and installing that initial customer, that validation is done so that you have the confidence that the service is going to work. Number two is, as we heard today, there's a lot of web-based self-management that we want to provide the end user. Now, in order to do that, you need checks and balances. So the assurance solutions can actually look at those changes, validate them as part of the service chain to ensure things are working properly. And lastly, it's all about monitoring that service once it's live, whether initial birth or as those changes are done, and having that real-time view to provide kind of insights and predictive view of how the service is working so that you can avoid issues early.
Yeah, I think one thing that's interesting about this is when we think of assurance, people normally think of service assurance. I'm looking at this connectivity service, but I think what we're looking at here is now going deeper in and doing the assurance. You mentioned of the service chaining and perhaps of the NFV infrastructure as well. So I don't know, Chris, do you want to maybe comment a little on that?
Yeah, I think at the end of the day, the way I look at the SD-WAN is it's an overlay network, but most networks are overlay networks. And it's really just another network domain. And you could take that same picture of the last slide and apply it to an SD-WAN domain. Yes, it's got some links, the underlay network that's serving it, et cetera, but it's exactly the same problem space. You don't always use the same technology because there might be differences in the different domains that are taking place, but it's very similar. And so the SD-WAN vendors have come out and they've done quite a good job of automation of their domain, but that doesn't mean they've covered all the ground. And so there's really a lot of additional work required to make sure that it's fully instrumented, that the information's there, and that you can actually trace, through the different service chains. So I think there's still a lot of innovation happening in this area, obviously.
And Patrick,
I mean, I couldn't agree more that in terms of the systems that come integrated with the SD-WAN solutions do provide some visibility, but it's really providing a degree of visibility that's more towards, it's great for providing information to the end user as to how are these applications going across and that sort of stuff. But when something goes wrong, when the infrastructure that's underneath it, the virtualized infrastructure that may be comprised of 1, 2, 3 service providers that are pooled for this to happen, when something goes wrong, these tools don't always provide what's required to pinpoint and to reduce time to repair and to find where the issue is. And one of the things that happens is that, more often than enough, the actual service provider that is fronting this with its own brand is carrying issues that are often, that are caused by another vendor, another service provider, an internet, a broadband line that is not up to snuff. And you know, the operations people that belong to this fronting service provider don't have the tools to go down and really immediately pinpoint who of the three service providers behind are the cause of the problem and how to get back to, you know, to optimal operation. And in the end, the customer, the enterprise, doesn't care. He'll blame the fronting service provider, even though it's been sold a service that's, you know, supposed to be lower cost, that's supposed to be, you know, more redundant, and so on and so forth. When something goes wrong, it's more difficult, it's more complex to fix.
And I think it's actually more complex.
Yes.
I mean, this is what's happening is the network domains are now not just physical network elements, they're a combination of physical network elements and virtual network functions connected in some topology. And so it's more complex. There are more failure modes, and so you really need more of the technology.
Well, I think the other thing too along those lines is when it's virtual, you know, when it's physical, you know exactly where it is, right? When it's virtual, it could be moving around in time and space, right? So that provides additional challenges because that function, you know, maybe if it failed and it got moved over to another compute environment, you know, now it's moved from the last time, from when you instantiated it. So
that's why your inventory needs to be real time.
Exactly.
Yeah, right, exactly. Yeah, because you need that sort of real time awareness. So
yeah, and so you know the tools that come with the solutions, you know, do provide this end to end. Your application is good, but you know, being able to drill down and sectionalize the issue exactly in terms of the right direction, the right part of the network in a really quick fashion is super important. Otherwise, there's no point in having all this agility and flexibility and all that if something goes wrong and then it takes you 3 days to fix it. And so in the end, you know, an overlay is definitely required in terms of service provisioning and service assurance for sure.
Well, so now we'll pass it over to you.
So speaking of SD-WAN, you know, speaking of SD-WAN, and like you just brought up, I mean, one of the things that you know, some of the early feedbacks is that yes, it's super successful, extreme amount of pull from the market. You know, commercial success is, it smells good. It's happening, maybe not as fast as expected, but all the good signs are there, and it's really picking up in a great fashion. Now, the two areas that are maybe not as of interest or not as, you know, delivering as much as they thought they would be is A, the cost savings of SD-WAN are not there yet. They're yet to come, and hopefully they will come. But right now, deploying SD-WAN is as expensive, if not sometimes even a little more. But we're in the ramp-up phase. That's okay. Complexity, though, as you said, is definitely there. And again, I think there's more to come in terms of automating and all that. Now, what this picture shows is really kind of two different alternatives of what we've seen being deployed out there. So if you look at the left part of the picture, you see kind of the traditional you know, UCP method where basically you're deploying an SD-WAN device at every location, you know, running some kind of an x86, whether it's open or closed. There's these different implementations, but you have x86 at all locations. That is kind of the, I would say, what most of the implementations so far are doing. If you look at the right part of the picture, it's kind of this hybrid mode where you know, some service providers have started to do that, and we've seen that in Asia, we've seen that in Europe, and we've actually started to see that in the US, is basically a combination of sites where you do install an x86 and other sites where you actually virtualize the SD-WAN capability one step inside at the closest POP, the closest data center. And now you're going to say, well, what's the point? I mean, you're basically losing the reliability or the redundancy of having two feeds. Well, you can supplement that by actually having you know, a closer location to the actual end user. And so you're basically pooling that at an actual location where you're basically just extending a very short tail of fiber across the street, whether it's a partner fiber, whether it's your own fiber. And the idea here is that having the environment there centralized allows you to pool that x86 interface, not having to worry about having this box that is frankly more expensive than expected, which has to be, a server that's got, the carrier grade ruggedness. It's actually sitting at the enemy location, if you want. It's exposed to, everybody tampering with it, and so on and so forth. And frankly, just in terms of cooling, in terms of environment, and so on and so forth, having that location is much more comfortable, if you want, for the carrier. And then all you need is extending a port from that location to the end user. Yet you're still leveraging all of the flexibility, the agility, and even behind that data center, you can actually pool and dole the traffic out to multiple service providers, and yet realize the flexibility and the bandwidth gains of SD-WAN. So we've actually started to see that. It's something that's called wires only. There are service providers that are starting to call it that way. It's also called virtualized SD-WAN, where ironically enough, it's kind of a misnomer because it should be virtualized in the first place. But bottom line, the idea is that it doesn't necessarily need to be installed at every location. Doing the combination, and install it where it makes sense, when it makes sense, may prove to be the right model of how to deploy that. Now, on the other hand, what you do need to still provide at the end customer prem, in the case where you are virtualizing it, is still have that visibility, that NID capability where you can actually troubleshoot, test, loop back, the classical stuff. And yet, if you're actually virtualizing some of the data capturing capability right next into the same data center, then you can start to have this interchange between the virtualized SD-WAN and the actual source of assurance data.
Okay, great. I'll tell you what, I'm going to jump to the next slide here. So back to you, Chris.
Sure. So this looks like the same picture as the last time of an LSO. The difference is that it's the conceptual framework. So in the previous version, we were managing network domains. In this version of the picture, we're talking about managing NFV domains. And so the fulfill change systems you see on the right are kind of what you would often be referred to as an NFV orchestrator. And you still need that real-time topology and inventory. The fundamental difference here is that instead of the services being a connectivity service provided northbound, such as a DWDM service or an Ethernet service, an IP service, people are trying to do that same closed-loop orchestration in the NFV world. And they need the same technology, but the service abstraction northbound is no longer a connectivity service with demarcation points. It's more of what you'd see as an ETSI NFV service. Right? So it's basically a logical function or almost a virtual network element with the demarcation points of the handoff. And the goal, you have to realize that one NFV data center will create VNFs that are going to be running in multiple different networks. I might be having a virtual router that's running in my Ethernet network, and then I've got a virtual EPC running in my wireless network, et cetera. And yet I've got that shared data center. And so you want to isolate all of the relationship between the compute infrastructure and the VNF and its performance to just one place. So one orchestrator that takes care of that so that all of the other domains don't need to. And so it's just a different way of organizing the LSO function into not just using LSO for connectivity kind of services, but using the same conceptual framework for NFV domains.
Yeah, and I think getting back to your point here, so you still need service assurance for your SLAs, but because it's not a connectivity service, it's more of a fixed point, and it could be in various places. You now have to look at, the compute environment, is the server environment up and running, et cetera. So you're using different, as you mentioned earlier, different technologies, but you still have to do service assurance. Is the thing up and running? If I'm going to offer an SLA that maybe it is for a managed router service, it has to be, you're looking at different things. Now you're looking at NFVI, infrastructure types of things, as opposed to connectivity service where, you might be doing end-to-end service assurance packets, to make sure you got end-to-end connectivity.
Exactly, and the ones who's in any NFV, anyone, if I'm running a network, okay, I'm running one of those network domains, I'm going to be using some VNFs. So is this guy, so is that guy. Right. You don't want all of us to have to understand the relationship of the underlying compute up to the VNF. Right. You want that isolated in one place, and that's what this is all about.
So Claudio, any?
Well, I think this ties very well in terms, whether it's network service or end-to-end service, it's understanding that infrastructure underneath, right? So compute resources, VNFs. One of the key things, obviously, we talked about topology, but the real value now with a lot of the assurance systems is they can be deployed in an automated fashion, very lightweight, right? So they minimize the amount of compute that's used. For example, we're demoing an automated closed loop assurance use case with Emeritus here in the POC showcase. But that same concept, which in this POC we're talking about end-to-end service, same concept of automation, LSO, and APIs relate to this as well, right? Mm-hmm. The ability to be able to kind of segment, look at different parts of the chain and being able to segment and validate the performance there. So I think that's going to be critical as service providers move to automation, to software-centric. They need to have some way of checking how the network is working, diagnosing the issues.
Okay. Let me go jump ahead here. I think this is your slide, Claudio.
Yeah, so I put this slide because obviously we're active in the LSO, but one of the things typically that service providers seen assurance solutions is kind of, we need to do it for our operations. You know, it's kind of a must-have to get our operations working. But we want to kind of also look at it in flipping it a bit in terms of how can we generate more business and more services and more competitive edge for the service provider. So one of the concepts within LSO is the ability to have, and we heard many speakers this morning talk about self-service web portal, kind of like we do as consumers, right? Providing that level of flexibility to the end user. So now by having assurance overlay solution, you now can augment the experience of the end user. So number one is, clearly they'll want to see performance monitoring, right? How is my performance behaving for my service today? We can actually, with a lot of these assurance solutions that from the panelists here, is provide a lot of visibility in terms of specific metrics and KPIs or KQIs for that service. The second thing is, as changes are done, I think people want to feel assured that, you know, things are working properly. So the ability to provide the end user with automated reports of birth certificates when things are instantiated, changed, provides that level of kind of self-service assurance, right, to the end user that things are working well. And lastly, I heard in the last panelist, they were talking about customers don't really want to call the help center, right? So providing them the ability through the underlying technology of tests and giving them the opportunity to do their own tests on demand and even troubleshoot their issues, right? Because they want to first determine, you know, is it on my side? I'll need to work there so I can reduce the mean time to repair. Or if they identify quickly that it's the service provider, have a much more pointed discussion on where that problem can be.
Yeah, so it's actually getting down to the root cause of it and being able to have you know, when you call the help desk, it's like, it's like when I have an issue with my broadband at home, you know, I call up and they say, yeah, they want to walk you through all the basic stuff. It's like, can I talk to your tier 2 person? Because, you know, I've already powered it off. I've done all that stuff, you know, and I think a lot of, you know, people want more control over that, you know, like you were saying. But Patrick, I don't know if
I fully agree. There's a lot of demand for, you know, for these enterprises to be able to, you know, in a really quick fashion, be able to do their own determination. Because in the end, I mean, they're not always saying it's the service provider's fault. I mean, they just want to be able to fix it quickly. Right. And now, one of the things that I would say service providers should be sort of careful in embarking on that journey is that these enterprises, they speak a different language. And no matter how we'd like to believe that they were all born with a MEF certificate in their hands, they're not. And so they don't speak MEF language, they don't speak ETSI, they don't speak you know, IEEE or ITUT. They speak, you know, IT language, right? And so from that standpoint, the way this information has to be presented and the way it has to be crafted so that they can utilize it on their own has to be with the IT user in mind. And so that's certainly something to bear in mind as these services are being offered.
That's a really good point, because I know a lot of times, I mean, you know, we're among our common professionals, and, you know, we talk in a language. I was used to joke with a friend of mine. We would go out at a restaurant, we get all geeky talking about all kinds of like really cool stuff. And I said, wait, imagine somebody sitting at a table next to us. They they thought we're from Mars, in terms of what we're talking about. And we just have to be really careful because, when you're presenting this to the customer, let's present it into something, that's meaningful to them instead of getting into all the technological terminology and stuff, right?
I think one other point, first of all, I fundamentally agree that this is going to be a differentiator for service providers if they can do a really good job of telling people their operational state of their service and their performance, not just give them control to change it. But one situation that I found really interesting that happened was a service provider that I was working with had done all that, and they were presenting the external view to the customers. But because they were manually configuring all their service OEM stuff, they'd make mistakes. And when they're making mistakes, that meant that the service OEM was reporting sometimes 100% frame loss. They would report that out to their customers, even though the traffic was going great.
Right.
And then the service provider said, well, no, I don't want to give you credits. And they said, well, then prove your service was working. And they actually turned it off because they didn't have a mechanism in place and enough automation in place to make sure that it was done right. So you really have to do these things with care.
Yeah. Okay, well, let's jump back to Patrick here.
All right, for a completely different topic. So just for a moment here, let's talk about real life 4.5 and 4.9. So 4.9G, tongue-in-cheek. But you would be surprised as to how many service providers, mobile operators out there are actually looking to extend the life of their 4G LTE, with LTE Pro and other things. And what we're starting to see out there in some places like Asia and parts of Europe is, the deployment of 10G to the tower environment. That is starting to be a reality. It's something that we had been anticipating for a couple of years. It actually took a little longer, but it's now a reality. And several projects to that effect even are starting in the US for sure. Now, crossing that cost barrier is really important, and facilitating that is super important. But there's also other aspects that 4.5 and 5G, will basically force into the service assurance and performance assurance world. So, mesh monitoring versus hub and spoke is going to become a reality because of the X2 interfaces and the importance of coordinating, the multi-carrier aggregation schemes out there. The ability to test as well the full 10 gig in a mesh fashion as opposed to just hub and spoke. That is quite a challenge, and it has to be tackled. Ultra-high precision and ultra-high granularity to tackle with, the ultra-low latency that's going to be required of the backhaul for things like 5G. The scalability of the solution, just because the amount of flows and the amount of end-to-end, but also any-to-any connectivity that's going to have to be monitored is going to really augment exponentially. And then finally, when it really goes to 5G, I would say service providers, even with 4.5G, they're looking to own the actual end user experience much more, and therefore are going to be looking for ways to do what's referred to as application-aware network performance monitoring. So basically, owning a network that is really a bearer of applications as opposed to a bearer of packets. And those are really the things that we're seeing really hitting the requirements list right now with these large mobile operators, but also hitting the requirements for backhaul.
Mm-hmm. Yeah, and I think this is an interesting area. I mean, we're talking about backhaul in particular, but if you look at even IoT and just wireless in general, LTE, and then eventually 5G. I think we're introducing service assurance is going to play a really key role, with things. I know we're getting a little off topic, but in terms of like 5G, you have connected cars and all these other applications that we normally don't think of, in this room, in terms of, connectivity services and stuff like that. So this whole real-time service assurance and awareness of this is going to become more and more critical. I don't know, anyone else want to comment?
I think Patrick brings a good point in terms of the stringent nature with 5G in terms of latency, right? Latency is going to be kind of the underpinning.
Right.
You have to keep it within a certain spec. And that's going to be something that in the past I think was kind of a little bit of an oversight. I mean, some people obviously are doing backhaul monitoring, but with 5G and the preparation for 5G, this is going to become critical, right? And that's an area that we play in, obviously. Accedian as well. But in terms of understanding in real time, the performance is going to be critical because all the video services, we heard Verizon mentioning 80% of the bandwidth is going to be video. That's going to be critical to have the right performance in that segment.
Yeah, Chris, you want to?
I'm actually on the fence on this one a little bit in terms of what's going to happen here. I'm seeing a lot of work in 5G networks and such around ensuring very low latency and of course different classes of service for different types of applications. What's been happening though for everything that's working over the internet so far is they've found a way to implement it in such a way that they're very tolerant to delay variation and frame loss. They build the applications so they'll do appropriate buffering, et cetera. Right. And sometimes it causes issues, like on a conference call where you get too much delay, so you end up talking over yourself. But for most of the applications, they manage to do it in such a way that it's tolerant. It's going to be interesting with the Internet of Things whether there's a bunch of applications that absolutely must have that real-time interaction or not. Mm-hmm. If they do, it's going to change the cost of the infrastructure. It's going to change the complexity of the configuration, and it's going to absolutely make the assurance essential. Mm-hmm. The only other way of doing it is to do a lot of local processing, because it won't be okay if your car is driving itself and it sends a transaction back because you're about to hit a post.
It takes too long, right? Yeah.
And it says, oh, sorry, let me just a bit of delay. So that it would have to act locally. Right. And so that's going to be, I think, an interesting thing that we're going to see in 5G is whether the applications end up finding a way to be tolerant or whether there are some that absolutely require that level of...
Yeah, that's actually a really good point, because if you look at applications that were designed to work over the internet, right? They'll compensate because they know, hey, this is the internet, this is the best I can get. Right. I'll compensate. Skype did a great job at that, making really, high, the broadband codecs and everything. But yeah, but like with connected car, like you said, if you need real-time telemetry to know your situational awareness of other cars around or highway conditions, you need that in the application may not be able to compensate for that.
Right.
Yeah.
That's the question.
I think the applications themselves won't have an issue whatsoever. I think where the stringency of things like latency, jitter, packet loss, and these things does increase with 5G is really with the underlying infrastructure, like the underlying 3GPP defined interfaces between each of the towers. And so these X2 interfaces. So if you imagine a character in the middle of that kind of square there that's getting beamed traffic from 4 towers or 3 towers at the same time, these 4 or 3 towers have to coordinate in ultra low latency real time to make sure that they just don't bombard the useless traffic or redundant packets that have been duplicated and so on and so forth.
Part's mandatory to do
so that and the handoffs and so on and so forth. And so those are the parts that are really getting into even lower latency land compared to 4G. So but the applications for sure will be more robust than ever. No kidding.
Okay, great. So moving on to totally something new, right,
yeah,
Chris?
So my last topic, this slide, it's about a concept called LSO Federation. So in the previous slides, I showed you an LSO that's managing a particular domain, and it's kind of done in isolation. You do closed loop of that particular network domain, that transport. On the left here, what I've drawn is a picture of a real-world network inside a service provider that has multiple different network domains. In this case, it's got an IPVPN network, an MPLS network up on the top that's providing IPVPN service to the end customer. But that network can't reach a bunch of the sites on the outside. So what they're doing is they're going down to their Ethernet network to get an Ethernet service to get access in 2 of the areas, and they're going to a DWDM network to get a Lambda access in another area. And then even the Ethernet network domain B can't reach, and so there's a local transport that already has some capacity out there. And so this is actually the way networks are built in a very hierarchical way. And so you get, and so the idea is that you've got an LSO implementation per domain. And an end-to-end service actually only goes across the domain. The IPVPN service at the top there is going only across that domain. But what's happening is services from one domain are resources in the other. Mm-hmm. Mm-hmm. And so if I take an assurance view of this, for example, a failure that happens down at the transport domain C, and if I look at what happens on the right, is I got that LSO C that's managing that. It realizes that there's a fault. It realizes its end-to-end service has failed. and it sends a notification northbound to its client, which is LSO-B, so that's Ethernet domain B. And it's aware then that its service, it then calculates what that means to its customers. And it realizes it's going to cause a failure northbound, so it sends a notification to LSO-A. And therefore, the network operator, the guy who's running the IPVPN network can say, okay, either there might be closed loop in there and protect it so that the end service is protected, or they then are able to inform their customer of the failure. But they know that the problem actually is way down in transport domain C.
Right.
And so that whole notion of LSO Federation, and the same concept can apply for provisioning down or for assurance up. And so really understanding that that's the way networks are built, and doing that kind of LSO federation is something that's starting to happen.
Yeah, and I think this is an area, a great new type of project. I mean, now that you're LSO committee co-chair,
yes.
This is a great, because, you know, a lot of the view is, you know, you start off simple, walk first, then run. And so the simple, you know, to start off with, you know, looking at LSO, but then federating it not only within your own, you know, your own network, but between, you know, federating it between, you know, different providers as well. So,
Exactly.
Well, I'm going to jump to the next slide since we're getting really tight on time. So, Claudio.
Yeah. So in this slide, essentially, what we've been talking about automation, right? Today, LSO. That's one of the main areas that we want to facilitate. When you move to an automated service delivery, it's critical that you also start thinking about automating root cause, right? And how to identify and pinpoint issues. So essentially, a little bit on the slide that Chris just showed, if understanding the transport or the network connectivity and how things are interrelated, understanding what services are running on top of that network, and then which customers are engaged in that service, right? Having that and matching that with KPIs that are coming from real-time performance creates kind of the key pieces to start working towards automated root cause, right? So for example, I put a couple of steps here. You can imagine a real-time assurance solution identifying predictively some issues, right? A degradation on loss or latency, for example. Then being able to send that information to a real-time topology system. The topology system then, knowing the way the network is configured and interconnected, then being able to pinpoint, based on these KPIs, and let's say the top N report, the top 10 worst sites, then provide visibility into these are the areas in the network that are most likely the cause of that problem, right? Get that information early, do that in an automated API-based fashion, and then provide that visibility to the end user to avoid the swivel chair, because the reality is today there's a lot of swivel chairing, there's looking at spreadsheets, trying to figure out what's going on. And many times, the result is issues get solved in days, weeks, right? And sometimes, worst case, don't even get solved, right? And get circumvented. So automated root cause is key, and it's the first part of what I'd call the full automation, where once you have that, if you close that loop with an orchestrator and the policy engines, you're now being able to self-heal with that information, right? So that's kind of the next phase of automation, but doing this is going to become critical to really operationalize the LSO-based services moving forward.
Yeah, and I think along these lines, I mean, that'll allow you to create stronger SLAs, you know, much more competitive SLAs. And this could feed into, you know, a whole topic of AI, which I know is well beyond the scope of we have time for in the couple minutes. But let me ask Patrick. You know,
I fully agree. I mean, one of the things that is often forgotten, I mean, is exactly just that. I mean, a lot of emphasis is put on automating service turn-up, you know, on automating, you know, self-upgrades of the network and bandwidth on demand and that sort of stuff. And this is super important. But I would say the automation of root cause and troubleshooting, you know, automating of troubleshooting is super important. I mean, setting up a service in minutes is great, but if every time something goes wrong, it takes you, you know, several days to fix it, you're back to square one. And these things always happen. There's always something that goes wrong, especially in the first few weeks of a service being turned up, and not having, you know, the ability to automate, you know, and accelerate, you know, the resolution to these issues is really missing half of the picture. So definitely in full agreement with that.
I think it's critical. I think that the reason why it's not hard technically to do this. The hard part is that the data is wrong. And
okay, what do you mean? What do you mean by that? Yeah, let's see.
Yeah, because the topology is wrong when it's coming up, or your clocks are set wrong, or the information or the tests are configured incorrectly. As a result, you can't trust the results of it. And so that's why people have to get involved all the time, is to go back and look at all that data and figure it out and reinterpret it. And until you get to that level of quality and that level of where you can trust the output of this, they'll never close the loop and go fix it. Because otherwise you're more likely to break something worse. So there's a lot of work that needs to go to make this become reality.
Okay, well, Patrick, on the last slide here.
I'll try to go quickly through this because there's a lot of information there. But bottom line, you know, what I'm trying to say here is that what really does affect the end user experience, you know, the IT guys in the enterprises, you know, what really affects them is completely different from a lot of the things that the carriers are currently architecting and monitoring. You know, when you look at it, and it really varies on an application per application basis. If you start to the left, web browsing has different, I would say, susceptibility to the actual impairments than streaming apps and cloud-hosted apps. If you look at web browsing, it's all these very small, very quick sessions that, you know, that are born and dead in few seconds, and there's so many of them that it's hard to keep track of them. And it's going to get even worse with, you know, microservices as they start expanding even more. Streaming apps, it's the opposite. It's steady throughput. Cloud-hosted apps, it's transactional, and then you get all of a sudden a burst because there's a file being downloaded or whatnot. And when you look at, you know, the measurement tools that are being used by the IT folks, I mean, obviously completely different than what the carriers are using. They don't even see the same picture. I mean, if you look at speed tests, for instance, you know, they basically focus on round trip time and what I refer to as raw throughput. NetFlow is more of a consumption, bandwidth consumption on a per flow basis, also focusing on raw throughput. In the end, you know, the effective throughput that's really, you know, represented by what the app user feels, you know, is very different because of things like retransmit ratio, window collapse rate, session setup time, which are all affected in various ways by the way the network's been configured. And so one of the things that's going to be important for a carrier to do in the years to come is put in place you know, the required infrastructures so that they can actually see and understand what their end users are feeling from their services. Try to own a little more of the end user experience, because just getting your hands back and saying, you know, I'm up to the SLA, you know, I'm up to the MEF specs, I mean, is not going to cut it in a very, you know, in a very competitive environment where the end user experience is going to be more and more important. So,
yeah, in fact, I think there's two really, really important things on this slide. One is it's all about the end user experience, right? Because that's, at the end of the day, that's all that counts. And then you have all the technical stuff in the right column. It's like, you know, those are the things we have to deal with in order to get a good user experience. The users, at the end of the day, really don't care about that other stuff. They just want it to, like, just make it work, right?
Exactly.
And so how do we translate, how do we address those things technically, but kind of hide and mask, you know, that complexity so the end user just gets a good quality of experience and only needs to know what they need to know. Yeah. And like you're saying, the tools are relatively deficient, you know, as you indicated here.
Exactly, and one of the things that you often see is that, okay, I mean, you've upgraded your bandwidth from 100 meg to 200 meg or 300 meg, and when you're back to what you were doing, you still don't feel that much of a difference, right? I mean, in the end, and why is that? There's reasons for that, and those are the reasons why it doesn't make, you know, much of a difference. So those are the things that have to be verified and around which the network has to be, you know, upgraded or enhanced or optimized.
Okay, so just a couple quick comments, maybe Chris, if you have any, or Claudio.
I mean, it's another example of the language too. That's the language that they speak, whereas the language that we speak, and it's essential that translation happens.
Okay, any final comments?
No, I agree. I mean, end user experience, we have to get as close as emulating or understanding what's going on, right? With NFV and VNFs, I think one of the advantages from an assurance side is in the past it was very difficult or costly to get to the edge. Now with software and lightweight VNFs, you have the ability to kind of create tests that emulate this, right? So you can see a heartbeat of all those metrics in real time, right? And be able to react quick.
Okay, great. Well, I'd like a round of applause for our panelists here. Thank you.